Hi there. Our lesson today is about revising how to work with numbers. So I'm going to start with this question in hands here. Working with numbers includes working with percentages, with ratio, with the map scale, with a simple interest, and so on. Let's start with this question that we have in hands here. A map has a scale of 1 to 50,000. A road in the map is 10 centimeter long. What is the real length of the road in kilometers? Now, I would like you to always know that 1 to 50,000, it means every 1 centimeter on the paper or on map actually represents 50,000 centimeter in reality, and that's how we write it. Now, let's read the question once again. What's given in the question? The 10 centimeter, which is on the map. So the 10 centimeter will go underneath the 1 centimeter on the map. What is my unknown? We don't know how much the 10 centimeter on map represents on reality. Once we organize the fact and the given information in the question, we actually cross multiply. We cross multiply. And when we cross multiply, we immediately write my unknown or my question mark is equal to and fraction line. What is my question mark multiplied by? It's multiplied by the 1 centimeter, which makes it my denominator. The other two numbers are 10 and 50,000. They go up as numerators multiplied by each other. And if you calculate, you're going to end up with 500,000 centimeter is the real length of the road. But note, they asked for it in kilometers. Accordingly, we know this fact. Every 1 meter is actually equal to 100 centimeter. And I found 500 centimeter, so it goes right underneath the 500 centimeter, and the meters is unknown. Let's cross multiply. So when we cross multiply, we immediately write my unknown is equal to and fraction line. My unknown, which is the question mark, is multiplied by 100. So the 100 goes down as denominator. The other two numbers are 1 and 500,000. They go up as numerators multiplied by each other. Cancel the zeros and you will end up with 500 meter is the real length of the road. But again, look at the question. They asked for it in kilometers. So there is one more fact that we have to take into consideration, which says every 1 kilometer is actually equal to 1,000 meter. Now I found the 500 meter, so it goes right underneath the 1,000 meter, which makes the number in kilometers as unknown. Now let's cross multiply. When we cross multiply, we immediately write my unknown is equal to and fraction line. What is the question mark multiplied by? It's multiplied by the 1,000. So the 1,000 is my denominator. So the 1 and the 5,000, they go up to the numerator multiplied by each other. Cancel the zeros and the answer will be 5 kilometers is actually the length of the road in reality. Let's have another question based on the exact same concept. Now they're giving you the area of the farm on the map as 6 centimeters squared. What is the real area of the farm in hectares? Okay, like I said, you immediately state that every 1 centimeter on paper is actually representing 50,000 centimeter in reality. What is given to me? The 6 centimeters squared, which is the size of the farm on the map. So the 6 centimeter will go right, before we do that, 1 centimeter, it represents the length. It does not represent the area. So that's why we're going to take all this to the power of 2, which means 1 centi times 1 centi, it's equal to 1 centimeter squared. 50,000 times 50,000, okay? In other words, 50,000, it's 5 times 10 to the power of 4, which makes it 25 times 10 to the power of 8 centimeter squared. Now, what's given to us is 6 centimeters squared, the size of the farm. On the paper, the 6 centimeters squared will go underneath the 1 centimeter squared, which on map, which leaves the size in reality unknown. Let's cross multiply. When we cross multiply, we say our unknown is equal to and fraction line. What is the unknown multiplied by? It's multiplied by the 1. The other two numbers, which is 6 and the 25 times 10 to the power of 8, they go up multiplied by each other as numerators. And this will bring down our answer in standard form as 1.5 times 10 to the power of 10 centimeters squared is the real area of the farm, but in centimeters squared. They asked for it in hectares. We know this fact that every 1 meter is actually equal to 100 centimeter, but we're looking for measurement units of area. So we're going to take this to the power of 2. So 1 meter times 1 meter is actually equal to 1 meter squared. 100 times 100, it's going to be 10 to the power of 4 centimeters squared, which is 10,000. Now, what I found is 1.5 times 10 to the power of 10 centimeters squared. So it's going to be placed underneath the 10,000 centimeter squared, which leaves the meter squared unknown. Let's cross multiply after we arranged the numbers. And when we cross multiply, we immediately write my unknown is equal to and fraction line. Ask yourself, your unknown is multiplied by the 10 to the power of 4 or the 10,000, which makes it my denominator. The other two numbers, 1 and 1.5 times 10 to the power of 10, they go up multiplied by each other as numerators. When we simplify here, so 10 to the power of 10 over 10 to the power of 4, we're going to subtract the powers. 10 minus 4 is 6. So the answer will be 1.5 times 10 to the power of 6 meter squared. But they asked for the area in reality in hectares. And this brings us to the fact that every 1 kilometer is actually equal to 1,000 meters. Now, we need the measurement units in area or for the area. So we're going to bring all this to the power of 2. So 1 kilometer times 1 kilometer, it's going to be 1 kilometer squared. And 1,000 times 1,000, it's going to be 10 to the power of 6 meter squared. Now, what we found is 1.5 times 10 to the power of 6 in meter squared. So it will go underneath the million or the 10 to the power of 6, which leaves the kilometer squared unknown. Let's cross multiply. When we cross multiply, we immediately write question mark or my unknown is equal to fraction line. What is the question mark multiplied by? It's multiplied by the million or the 10 to the power of 6. The other two numbers are 1 and 1.5 times 10 to the power of 6. They go up as numerators multiplied by each other. 10 to the power of 6 over million, it's exactly as 10 to the power of 6 over 10 to the power of 6. So they're cancelled. So the final answer is 1.5 kilometers squared. Now, look at the fact that's written in the question. It says every 1 hectare is actually equal to 0.01 kilometers squared. So the 1.5 kilometers squared is going to be placed underneath the 0.01, which leaves the hectare unknown. And to find the hectare, we're going to divide the 1.5 by 0.01, and the answer will be 150 hectares. Let's go to the next question, which represents ratio. So, when we are talking about ratio, I want you to start by designing your beautiful ratio table, which is composed of initials, ratio numbers, and number of people, because the numbers that are mentioned in the question here represents number of women, number of men, number of children, and they're all people. Let's get our table organized. So that's our first column that is composed of initial, ratio numbers, number of people. Now, in the initials, as it is written in the question, M for men, W for women, C for children. And then at last, I want you to put the total, and I will explain what does that represent. Now, in the exact same sequence, the ratio of men is 6, women is 7, children is 3. The other number that is given to us in the question is 42,000 women. So the number of women, number of people, number of women, it's going to be 42,000, which leaves this as unknown, the number of men as unknown, and the number of children and the total number of people. Now, to find the total number of ratio, you simply add the ratio numbers, which is going to add up to 16. Now, we need to find a number that we must multiply all the ratio numbers by. How do we find out this number? We basically have the ratio of women given and the number of women is given. So we're going to divide 42,000 by 7, which brings it down to 6,000. So every single number in the ratio is going to be multiplied by 6,000. 6 times 6,000 is 36,000. 3 times 6,000 is 18,000. 16 times 6,000 is 96,000. To check on your work, just add the number of people. You must end up with the total, which is 96,000. Now, the number of children in Newtown is 18,000. The number of, or the total number of people is 96,000. Let's get to the second part of the question. 42,000 women is an increase of 20% on the number of women 10 years ago. Calculate how many women lived in Newtown 10 years ago. So now it turned into a percentage question. When we talk about percentages, we start with our OCN table. Let's create our OCN table, which is composed of 3 rows and 4 columns. Start with the second column, first row, original for O, change for C, and then a new for the N. And the first column, second row, it's the percentage. The third row or the last row is the number, and here again it represents the number of people. Now, the original is always 100 as a percentage. The 42,000 is the number that is given to us in the question, which represents the number of women, the new number of women, because they asked for the original number or the number of women 10 years ago. Now, the 20, it represents the change. And since it's an increase, as they mentioned in the question, 42 42,000 women is an increase of 20%. So we must add the 100 and the 20, and the answer will be 120. Now, what is missing here is the original number of women. Like I said, once we organize the given numbers in our OCN table, we choose two columns, the first and the last. Why the first and the last? Because there is only one unknown in the first and the last. The 100 is known, the question mark is unknown, the 120 and the 42,000 are known, so we can immediately cross multiply. And when we cross multiply, we say question mark equals to and fraction line. What is my question mark multiplied by? It's multiplied by 120. So my 120 will go down as a denominator. The other two numbers, the 100 and the 42,000, they go up as numerators multiplied by each other. Use your calculator to calculate, and the original number of women, or the number of women 10 years ago, was 35,000 women. The one more thing that we're going to talk about today when we're working with numbers is sequences. And again, they're asking for the 10th term and the nth term. But I would like you to always find the nth term at first. Now I would like you to design our beautiful sequence table, which is composed of so 1, 2, 3, 4 rows, and then the first column there is the n, and then the numbers in the sequence, the numbers that are given to me in the sequence, which is 4, 9, 16, 25, 36, and so on, and then something that is called the term-to-term rule. Now, as for the n, for any sequence in the world, it's always 1, 2, 3, 4, 5. Underneath the 1, which represents the first term in my sequence, is the 4. The second term is the 9. The third term in my sequence is the 16. The fourth term is the 25. And at last, the fifth term is the 36. The term-to-term rule, now from 4 to 9 to 16 to 25, my sequence is increasing. So I must be thinking of addition or multiplication, right? Now, here from 4 to 5, from 4 to 9, we're adding a 5. From 9 to 6, we're adding a 7. From 16 to 25, we're adding 9. From 25 to 36, we're adding 11. As you can see, the term-to-term rule is not consistent. It's not increasing by the exact same number. So that's why we have to go to the second degree of the term-to-term rule. Now, from 5 to 7, we're adding 2. From 7 to 9, we're adding 2 as well. And then from 9 to 11, we're adding 2. Now we can write the nth term. As you can see, the nth term is going to be quadratic. So if you look at 4, 9, 16, 25, 36, they are squared numbers, meaning the 4 is actually equal to 2 to the power of 2. The 9 is actually equal to 3 to the power of 2. 16, 4 to the power of 2. 25, 5 to the power of 2, and so on. So 2 to the power of 2, okay, the 2 is actually, if I want to make a relation between the 2 and the 1, so it's minus 1. Here, 9, it's 3 to the power of 2. If I want to make a relation between 3 and n, which is 3 and 2, so it's minus 1. Again, the 16 is 4 to the power of 2. If I want to make a relation between the 4 and the 3, it's gonna be minus 1. Accordingly, my nth term will be n plus 1 all to the power of 2. So if you substitute n as 1 at first, 1 plus 1, 2. 2 to the power of 2 is 4. So I got the first term in my sequence. If n is equal to 2, 2 plus 1 is 3. 3 to the power of 2 is 9, which gives me the second term in my sequence. If I go for 5, n as 5, 5 plus 1 is 6. 6 to the power of 2 is 36, which makes my nth term correct. Now, let's solve for the 10th term. If n is equal to 10, then the 10th term is 10 plus 1 all to the power of 2. Let's simplify. So it's 11 to the power of 2. 11 to the power of 2 will be equal to 121. Now, let's get to this question. Shireen invests 10,800 and after 4 years, she has earned 3,240 in interest. At what annual rate of interest did she invest her money? So now we're talking about simple interest, which has a formula. And this formula, the I represents the simple interest, the P represents the sum of money, and then the R, it represents the interest per year, and then the T, the number of years. Okay, let's substitute in this formula. So if we substitute the simple interest as 3,200, this will make the 10,800 as the sum of money. R is my unknown. The number of years is 4, all divided by 100. So we're solving for R. We're solving for R. So we're going to say R is equal to and fraction line. Then I'm going to decide on my denominator. How do I decide that? I'll ask myself, what was the R multiplied by originally? By the 4 and the 10,800. So the 4 and 10,800 are going to be my denominators, which makes the 100 times 3,240 my numerator. So this is my R. Use the calculator to calculate, and your rate of interest is going to be 7.5. I just wanted to highlight here, what if some people switched that 10,800 with that 3,200? We're going to have this. So R is going to be, why is that 3,240 times 4 is my denominator? Because it was originally multiplied by the R, and which makes the 100 times 10,800 our numerator. And if you calculate, it's going to be 83.3. Does that make sense to you? I think the 7.5 as a simple interest makes more sense, which will bring this solution out. Now, this is our last question in this presentation, and it's about, once again, it's about the OCN table. In 1950, the population of Switzerland was 4,714,900, and in 2000, the population was 7,087,000. Work out the percentage increase in the population from 1950 to 2000. Like I said, once you see a percentage question, start with our beautiful table, which is the OCN, and it is composed of 3 rows and 4 columns. And then start in the second column, first row, with the original, O for original, C for change, and N for new. And then the first column, second row is our percentage, third row is our number, which represents the number of people in this question. The original as a percentage is always 100. Now let's get back to our question. So the 4 million represents the original number of population, and it increased, and so that the new number of the population is 7 million. To find out the change, we're going to subtract the two numbers, 7 million minus the 4 million. The answer will be here as 2,372,000 and 100. Now, this is unknown, and we figured out the change in the number of population since it started at a number and it increased to a new number. And this is my unknown that is asking for in the question. They asked work out the percentage increase in the population, and accordingly we are going to work with the first and the second column because I have basically one unknown. The 100 is known, the 4 million is known, the question mark is my unknown, and the 2 million is known. Now let's cross multiply. And when we cross multiply, we put the unknown is equal to and fraction line. What is my denominator? I ask myself, what is my question mark multiplied by? It's multiplied by the 4,714,000 and 900. So this is my denominator. The other two numbers, which is the 100 and the 2,372,000 and 100, they are my numerators, so they go up multiplied by each other. Use the calculator to calculate, and it's 50.3% is the percentage change. Now, the second part of the question, they asked us to write the population in standard form, the population of 2000 in standard form. And the population of 2000 was 7,087,000. Now, the standard form is actually written in this way: A times 10 to the power of n. A is a number that is greater than 1 yet less than 10. N is the index, is the power that when you multiply it by A, you must get back to the original number, which is the 7,087,000. Now, can we at first get rid of the zeros at the end of the number? I have 3 zeros at the end of the number, so it's gonna be 7,087 times 10 to the power of 3. I think we all agree to that, right? Now, the 7,087, which is my A, I must make it less than 10, yet greater than 1. So I'm going to write it as 7.087. And to get it back to its original value, which is 7,087, I must multiply it by 10 to the power of 3. And the other 10 to the power of 3 is already there. So when I multiply two power numbers like 10 to the power of 3 times 10 to the power of 3, we actually add the power. So the answer will be 7.087 times 10 to the power of 6. Thank you so much for watching, and I'm looking forward to see you tomorrow in another lesson about working with numbers. Thank you so much.